Hey, welcome back to Math with Patrick. It's April 19th, and we're solving problem number 109 together from the Daily Epsilon calendar. And the answer is 19. It's today's date. So it looks like an arithmetic problem to me. Like I'm going to just do these exponents, like multiply it out. Going to find what these numbers are and then finally divide them. I'm a little bit suspicious of these problems whenever there's a number that matches today's date. And then all of these 18s are just one less than that 19. So I'm kind of convinced if I replace the 19 with a 5, for example, and all of these 18s with 4s, that overall I would still get a 5. So let me just solve it with normal arithmetic rules. I'm not going to do anything weird and funky yet, but then I do want to see if I can generalize this and maybe show that this 19 isn't anything really special. I just have a hunch that this 19 could be any number, and then you plug in one less than that in all the other spots, and then it's true. So I'll save that for later. Let's just do the arithmetic. 18 cubed doesn't look that fun to compute, but 18 squared is already here. And so let me just find out what 18 squared is, and I'll use that to get 18 cubed. Squaring just means multiplying it by itself. So 8 times 8 is 64. 8 times the 1 plus the 6 is 14. Little placeholder 0 for my 1 or my 10, technically. And then 1 times the 18 just gives me 18. Adding up my parts, it looks like 18 squared is the same thing as 324. So 18 cubed should be one more 18 multiplied into there. So just running through the multiplication again, I see a 32. I see a 16 plus a 3. I see a 24 plus a 1. And then a placeholder 0. And then, the multiplying by 1 isn't too hard. Adding these up, 2, 13, carrying the 1 makes this an 8. And then this is a 5. So let me record that in my numerator, 5,832. And then I just need to figure out what 19 squared is. So, I guess I'll just do 19 times 19. The 9 and the 9 make an 81. 9 plus 8 is 17. Placeholder 0, 19, and then adding it all up gives me a 1, a 16, and then that 1 carries over and gets me 361. So 361, and then minus 18. The bottom is pretty easy. Just add the 1. And then the top is a little bit less straightforward. So I guess let's just run through the addition first and then subtract the 18 second. Okay, so we get a 3, a 9, an 11. So carrying the 1 makes us a 6. And then subtracting the 18, looks like I need to borrow a little bit. This 9 becomes an 8. This 3 becomes a 13. 13 minus 8 is 5. 8 minus 1 is 7. And then it looks like the 61, or I guess 6,100, remains untouched. So 6175. All right. Two ways to think about this. We could try finding some common factors and reducing this fraction. We could also use long division. Normally I'm a fan of the former strategy of finding common factors, but I don't really know, 5 times something is going to be 325. And then 5 times something else is going to be 6,175. But I'd have to use long division to figure out those numbers anyways. I can't factor these numbers really easily in my head. So if I'm going to use long division for my fraction reducing strategy, why not just use long division to start out with? I actually do notice that they're both factors of 25. You could even kind of see how writing them as money numbers, you could add up some amount of quarters to get to those numbers. So I do know I could actually divide both by 25 to reduce it down, but it's just going to be long division either way. So let's just, I guess, bite the bullet, so to speak, and do the long division right now. 325 I think just goes in once into 617 because another time, like 2 times, would be 650, so too big. And then subtracting, I get 2, borrowing, so that's going to be a 9, and then this will be a 2. Okay. This one's a touch harder. Like, how many times does 325 go into 2,925? It's not really that clear. But today's answer is 19, so, I'm cheating a little bit by like knowing the answer, but I would do this anyways. I like kind of guesstimate in my head. I'd be like, well, I know that 300 times 9 is 2,700 or 2,700. So times 9 isn't like a, oh, whoa, sorry. This was supposed to be a 325 times 9. It's not like a wildly weird thing to just kind of guess and check right now. I'm trying to just double check that I should put a 9 right here and then do 9 times 325. And hopefully I get to clear out all of this and get a remainder of 0. So 5 times 9 is 45, carry the 4. 2 times 9 is 18, plus the 4 is 22. And then 9 times 3 is 27, plus the 2 is 29. So great. That shows that yes, 19 is my answer here, and we're all done with the arithmetic side of things. Now, actually, before we try solving it with algebra, just a little disclaimer. I did originally solve it with that fraction reduction strategy where I like took a 5 out of the top and the bottom, and then another 5 out of the top and the bottom because, like a 25 was a factor for both. And it was just really long and tedious. And in fact, this like disclaimer plus the strategy with long division is shorter than doing it with that fraction reduction strategy, just because there's so many steps I had to go through. So when I flip over to the next clip, you're going to see a different whiteboard, and you feel free to pause to look at all the work that I had to do to like do it with the other strategy. And just know that it was better with long division for today. So let's try to solve this problem using algebra and variables now. But if you'll humor my curiosity, I really want to know what's going to happen if I try doing, let's see, x minus 1 cubed plus x squared minus x minus 1. Because that same idea where like this is my x and then all of these are 1 less than it. And then like I'm hoping that after doing all these algebra simplifications, I'll just be left with an x, because like that's how 19 showed up twice. X, I'm hoping, is just going to be the only thing left after I do all this algebra. So my denominator should be x minus 1 squared plus 1. All right, let's zoom into here, hoping that this just simplifies to an x. I don't really see a good way forward besides kind of just copying what I did already, like expanding out the cube, expanding out the square, and then seeing if I can simplify anything in the top and bottom. So x minus 1 times x minus 1, why not? Let's do that first. That's going to be x squared minus 2x plus 1. And so this x minus 1 cubed will be me multiplying another x minus 1 with this. So really quick, I'm trying to do all the distributions. We're going to get x cubed minus 2x squared plus x, and then minus x squared plus 2x minus 1. So this x minus 1 cubed is going to be x cubed minus 3x squared plus 3x minus 1. All right. X squared, I guess I'll just leave as x squared. And then I'll distribute this negative sign, so it's minus x and then plus 1. You know what? Let's just release these parentheses, because as long as I'm doing my addition and subtraction like left to right, like I don't really need to group it that way. Same thing in the bottom here. I don't really need to group these anymore, because all that's going to happen in the end is just add a 1 at the end. Let's see if I can simplify. Well, this minus 1 and this plus 1 go away. Let me color code that real quick, just to show that, I'm canceling a minus 1 with a plus 1. And, well, I don't see anything else really, so let me collect up my like terms. I have an x cubed still. I have a minus 2x squared, and then I have a plus 2x, right? Because I have plus 3x minus 1x. Cool, that's a 2x. And then in the bottom, I have x squared minus 2x plus 2. Ah, there it is. If I factor out an x from my numerator, then I'll be left with an x squared, a minus 2x, and a plus 2. I always say this, but like you can imagine redistributing this x into all three terms, and you're going to get right back to where you started. So that's how I can confirm in my head that this factoring of an x out is valid, and it's the same thing as what I had before. And then in fractions, when you are simplifying them, as long as you have the same factor in the top and bottom, you're allowed to cancel them. Kind of like how I canceled a 5 up here and a 5 down here when I was reducing these fractions. Technically, this factor and this factor, you can just cancel. And there's like nothing left in the denominator, but maybe you could think of it as a 1 instead of a 0, right? Multiplying by 1 doesn't really do much. And so that's what's left over when you cancel out both of these factors. And then x over 1 is just x in the end. So looks like that 19 was nothing special today. And, it could have been any number here. And with this weird setup and this weird fraction, the answer was going to be 19 all along. So thanks for coming along, solving this 2 ways. And I'll see you tomorrow. All right. Bye.